everyone, my name is Jamina Gatdula and I'm from Environmental and Sanitary Engineering 12S1. For this video, I will be tackling about factoring polynomials. Let's start out by talking about what a factoring is. So factoring is a process by which we go about determining what we multiplied to get the quantity given. For instance, here are the variety of ways on how we factor 12. First is 12 is equals to 2 times 6. Second is 12 is equals to 1 half times 24. Third is 12 is equals to 3 times 4. Fourth is 12 is equals to negative 2 times negative 6. Fifth is 12 is equals to 2 times 2 times 3. And lastly, 12 is equals to negative 2 times 2 times negative 3. There are many possible ways on how we factor 12, but these are the representatives of many of them. A common method of factoring numbers is to completely factor the number into positive prime factors. A prime number is a number whose only positive factors are 1 and itself. For example, 2, 3, 5, and 7. The following are the steps on how we factor polynomials. First is we determine all the numbers that were multiplied together to get the given polynomials. Second, try to factor each of the terms that we found in the first step. This continues until it's simply not factorable anymore. When factoring isn't possible anymore, then the polynomial is completely factored. For example, x squared minus 16 is equals to x plus 4 times x minus 4. This is completely factored since neither of the two factors on the right side can be further factored. Likewise, x raised to 4 minus 16 is equals to x squared plus 4 times x squared minus 4. It's not completely factored because the second factor can be further factored. Note that the first factor is completely factored, however. Here's the complete factorization of this polynomial. X raised to 4 minus 16 is equals to x squared plus 4 times x plus 2 times x minus 2. The purpose of this section is to familiarize ourselves with many of the techniques for factoring polynomials. Let me remind you of the GCF, or the greatest common factor. The first method for factoring polynomials will be factoring out the greatest common factor. When factoring in general, this will also be the first thing that we should try as it will often simplify the problem. In this case, we are only using the distributive property in reverse. Remember that the distributive property states that a times b plus c is equals to ab plus ac. In factoring out the greatest common factor, we do this in reverse. We notice that each term has an a in it, so we factor it out using the distributive property in reverse as follows. ab plus ac is equals to a times b plus c. For example, in letter A, 8x raised to the 4th power minus 4x raised to the 3rd power plus 10x squared. First, we can notice that we can factor out a2 and then x squared out of every term. So here then is the factoring for this problem. 8x raised to the 4th power minus 4x raised to the 3rd power plus 10x squared is equals to 2x squared times 4x squared minus 2x plus 5. Note that we can always check our factoring by multiplying the terms back out to make sure that we get the original polynomial. Second example, we have x cubed y squared plus 3x raised to the 4th power y plus 5x raised to the 5th power y cubed. In this case, we have two variables. They are the x's and the y's, but that doesn't change how the process works. Each term contains x raised to the 3rd power and a y, so we can factor out both of them, and doing this gives x cubed y squared plus 3x raised to the 4th power y plus 5x raised to the 5th power y cubed is equals to x cubed y times y plus 3x plus 5x raised to the 2nd power y squared. For the last example for this problem, we have 3x raised to the 6th power minus 9x squared plus 3x. In this case, we can factor a 3x out of every term. Here's the work for this one. We have 3x raised to the 6th power minus 9x squared plus 3x is equals to 3x times x raised to the 5th power minus 3x plus 1. we can notice that there is positive 1 left in the third term. Originally, we have 3x in there, but to remind ourselves that there was 3x in there, we put positive 1. We put positive because originally it is positive 3x and not negative. For the next case, we have factoring by grouping. This is a method that isn't used all that often, but when it can be used, it can be somewhat useful. This method is best illustrated with an example or two. For example, we have 3x squared minus 2x plus 12x minus 8. In this case, we will group the first two terms and the final two terms as shown here. For the first example, we have 3x squared minus 2x plus 12x minus 8. In this case, we will group the first two terms and the last two terms as shown here. Quantity 3x squared minus 2x plus quantity 12x minus 8. Now, we can notice that we can factor out an x out of the first grouping and a 4 out of the second grouping. Doing this gives 3x raised to the second power minus 2x plus 12x minus 8 is equals to x times 3x minus 2 plus 4 times 3x minus 2. We can now see that we can factor out a common factor of 3x minus 2. So let's do that to the final factored form. 3x raised to the second power minus 2x plus 12x minus 8 is equals to 3x minus 2 times x plus 4. For the second example, we have x raised to the fifth power plus x minus 2x raised to the fourth power minus 2. Again, we will group the first two terms and the last two terms, and it will give us quantity x raised to the fifth power plus x minus 2x raised to the fourth power plus 2. In here, we can notice that we used a negative sign between them because we have the negative 2x raised to the fourth power minus 2. Again, we can always distribute the negative sign back through the parentheses to make sure that we will get the original polynomial. So at this point, we can see that we can factor out an x out of the first term and a 2 out of the second term. So this gives x raised to the fifth power plus x minus 2x raised to the fourth power minus 2. It is equal to x times x raised to the fourth power plus 1 minus 2 times x to the fourth power plus 1. We now have a common factor that we can factor out to complete the problem. It gives us x raised to the fifth power plus x minus 2x raised to the fourth power minus 2 is equals to x raised to the fourth power plus 1 times x minus 2. For the next case, we have factoring quadratic polynomials. In these problems, we will be attempting to factor quadratic polynomials into two first-degree polynomials, henceforth the linear polynomial. For the first example, we have x squared plus 2x minus 15. Okay, since we have x squared on the first term, we now know that we will factor it out in the form of x squared plus 2x minus 15 is equals to x plus blank times x plus blank. So doing this, we should get all the possible factors of negative 15, wherein when we simplify those two numbers, we will get the sum or the difference of 2x, which is our second term. First, let us try out negative 1 and positive 15. When we multiply these two numbers, we will surely get the product of negative 15. But then when we simplify it, we will get the wrong difference. Next, we will try out positive 1 and negative 15. When we multiply those two numbers, we will surely get negative 15. But when we simplify it, we will get the difference of negative 14. Next, let us try out negative 3 and positive 5. When we multiply them, we will surely get the product of negative 15. And when we simplify them, we will get the difference of positive 2x. So the answer will be x squared plus 2x minus 15 is equals to x minus 3 times x plus 5. For the second example, we have x squared plus 6x plus 9. In this case, we have the perfect square of 9. So automatically, we will use its factor 3 times 3. So start with the initial form, x squared plus 6x plus 9 is equals to x plus blank times x plus blank. Replacing it with the factor 3 times 3, it will give us x squared plus 6x plus 9 is equals to x plus 3 times x plus 3. So since we have the common factor, we can also rewrite it as x plus 3 squared. Now, we also have the case called special forms. These are some nice special forms of some polynomials that can make factoring easier for us on an occasion. Here are the examples of the special form. First is a squared plus 2ab plus b squared is equals to a plus b squared. Second, we have a squared minus 2ab plus b squared is equals to a minus b squared. Third, we have a squared minus b squared is equals to a plus b times a minus b. Third, we have a raised to the third power plus b raised to the third power is equals to a plus b times a squared plus ab plus b squared. Next, we have a raised to the third power minus b raised to the third power is equals to 8 minus b times a squared plus ab plus b squared. For our first example, we have x squared minus 20x plus 100. In this case, we've got 3 terms and it's a quadratic polynomial. Notice as well that our third term is a perfect square and its square root is 10. And 2 times 10 is equals to 20, and this is the coefficient of the x term. So it looks like we've got the second special form from above. The correct factoring for this polynomial is x squared minus 20x plus 100 is equals to x minus 10 squared. For the second example, we have 25x squared minus 9. In this case, all that we need to notice is that we've got a difference of perfect squares, wherein 25x squared minus 9 is equals to 5x squared minus 3 squared. In here, we have 5 as the square root of 25 and 3 as the square root of 9. So this must be the third special form from above. Here's the correct factoring for this polynomial. 25x squared minus 9 is equals to 5x plus 3 times 5x minus 3. For the last case, we have factoring polynomials with degree greater than 2. In this case, there is no method for doing this in general. But then, there are some that we can do. So let's take a look at the examples on the next slide. For the first example, we have 3x raised to the fourth power minus 3x raised to the third power and 36x squared. In this case, let us notice that we can factor out a common factor of 3x squared out of every term. So let's do that first. We now have 3x raised to the fourth power minus 3x raised to the third power minus 36x squared is equals to 3x squared times x squared minus x minus 12. What's left is a quadratic wherein we can use the techniques from above to factor. Doing this gives us 3x raised to the fourth power minus 3x cubed minus 36x squared is equals to 3x squared times x minus 4 times x plus 3. Don't forget that the first step to factoring should always be to factor out the greatest common factor. This can only help the process. We did not do a lot of problems in here and we didn't cover all the possibilities. However, we did cover some of the most common techniques that we are liable to run into in the next other chapters of this work. So that is it for factoring polynomials. Thank you for watching and I hope you learned something today. Bye!